Okay, this is the remaining examples from the 2.6 notes. I'm looking at C and D from underneath example 4. We're trying to solve for x in the middle, so we're going to take this first one right here and multiply everything by 3 to clear out that fraction in the center. So this would be 15 is greater than or equal to 6 minus 5x, which is greater than 6. We're going to subtract 6 from all three sides since this is a string or compound inequality. That gives us 9 is greater than or equal to negative 5x, which is greater than 0, because 6 minus 6. We need to divide everything by negative 5. And because we're dividing by a negative, that's going to flip these inequalities. So I get negative 9/5, we'll leave that as a fraction. It's now less than or equal to x, which is less than 0. So in interval notation, this would be negative 9/5 with a bracket up to 0 with a parentheses. Okay, for D part, we need to get the x by itself in the middle again. First step I would do here is not actually going to be to multiply everything by 4. I only do that if the whole middle is a fraction. Since this is separate, and this is a 3 and this is a 1/4, I'm actually going to subtract 3 first. So this would be negative 5 less than 1/4 x less than or equal to 2. Now I want to get rid of that fraction, so I'm going to multiply everything by 4. So that would give me negative 20 is less than x is less than or equal to 8. In interval notation, that would be parentheses, negative 20, comma 8 with a bracket. Okay, we did E in class, so I'm going to scroll on down. I'm saving A, B, and C to talk about once we talk about the rational inequalities on our next class session. We did D and E in class, and I'm going to do F, G, and H because I did not get to all three of those in both of my classes, so we'll do those together. For absolute values, remember there's two types really, less thans and greater thans, and in each of those types there's two cases. So either the number, once you've isolated the absolute value, is positive or that number is negative. If it's positive, no matter if it's a greater than or a less than, you're able to solve and find an answer. Anytime it's a negative on the other side, once you've isolated the absolute value, you have to remember that in one case that's no solution, and in the other case it's all real numbers. And you just kind of have to think, does the sentence make sense or not? So for this first one, we need to isolate the absolute value. So I'm going to add the 0.03 to both sides, or excuse me, 0.3. That would be absolute value of x minus 3 is greater than 0.4. Since this is a greater than problem, greater than problems break down into two cases. The inside is going to be either less than the negative of the number on the other side, or the inside is greater than the positive of that case. Now you can only use this setup if you have a positive number on the right side. So this would be x minus 3 is less than negative 0.4, or x minus 3 is greater than 0.4. So we add 3. You need to line up your decimals. Sorry, this would be right here. So this would be x is less than 3 minus 0.4 is 2.6. And this would be to add 3. Notice these are decimals already, so that's why I'm keeping them in a decimal format. So I have two situations. Either x is less than 2.6 or x is greater than 3.4. You write these from least to greatest, so negative infinity to 2.6, union, since there's a gap between the rest of our answer, and 3.4 to positive infinity. Okay, let's look at G. We would start off by isolating this, so we're going to add 2. And I'm actually going to change this to a less than problem, just so we see a different variation of something to solve. So if we add 2 over, that'll be 12. Divide everything by 2. That makes absolute value of negative 11 minus 7x is less than 6. Separate this out from the previous problem. And then this is a less than and a positive. So if you have a less than and a positive, you set the inside between the value that is negative and positive of that number. So it looks like this when you have a less than case. This is an or case, this is an and case. So our inside is the negative 11 minus 7x, because that's what's inside the absolute value. So we add 11 to all three sides, so that would make this 5 and 17. And then we're going to divide everything by negative 7. Now, what happens here is when you divide this, it changes the direction of your problem. So this would be negative 5/7 is greater than x, which is greater than negative 17 over 7. In this scenario right here, the reason this is a little troublesome is that this is not from least to greatest. So because you have the greater than first, that means this is the biggest number. So to fix that, you just write them in the opposite order. Smallest number to largest number. So there's my interval notation. And then for the last one, this is a special case because this is an absolute value less than or equal to a negative on the other side, and it's already isolated. So when we look at this, you have to ask yourself, is this a true or false statement? If it's a true statement, then you would say it's all real numbers. If it's a false statement, you would say it's no solution. Absolute values, no matter what you plug in here, if you take an absolute value, the answer comes out positive. So the question is a positive number ever less than -2? And the answer is that that is always false. So it's not true at all. So if something is always false, that means there's not a solution. Or no solution is another way of saying that. So that is the end of the 2.6 catch-up notes. And like I said, the 3 that I skipped that were fractions will get covered with the group that we do on our next class session.